it's tight.
You know, we're trying to go to some whole foam systems, and
yeah, I don't know that you can get much tighter than 0 point.
So good afternoon. We're headed over to our Bailey's Point Lake house that we built last year. And we're going to do a blower door test today. If you're not familiar with that, it is a test to basically determine how much air infiltration a structure has. This is the first one that we've ever done, and I'm just really kind of curious how this house shakes out. We had done quite a few things to try to airproof it using zip liquid flash on our penetrations and things. It is a Bibbs insulated house with foam on the roof decks, so it's kind of a hybrid. And we're going to just kind of use this as a baseline moving forward for kind of where we hit with our air infiltration. And we're going to start trying to do blower door tests on pretty well every house. That's probably going to become an energy code requirement in the future. And we're just, for one, going to be ahead of it, but for two, I really do believe that it's a great source of us being able to save resources if we're just trying to be as efficient as we can with these things. So we're going to learn a little bit about blower door test and take a look at how this house performs today. So I'm here with Steve, and Steve, who is it you're with?
Clark Home Energy.
Okay. And how long have you been doing this?
Since 1993, so about almost 30 years.
A few years, huh?
Yeah.
And Steve was telling me a minute ago, a lot of what he does is checking this out because it's more of a winterization thing for people in older homes looking to try to make sure their home is sealed up and going to be a little bit more efficient going into the winters, correct?
Yes,
And but today we're going to see how many air turnovers we have in here. And this device is the blower door we were talking about. And Steve, it's going to try to suck air out of the house, right?
Yes, it's going to. It's a Minneapolis blower door. We'll put a 50 pascal pressure on every surface of the house at one time. About 50 pascals of pressure reading, kind of like PSI in your tires or whatever. It equates to basically like a 20-mile-an-hour vacuum on the house. And then we're measuring cubic feet per minute, how much air is leaking through the fan.
Yeah, and so it's really trying to literally suck the wind out of this place, and we're able to see how many air turnovers you have, which then we wind up determining when we need to install makeup air and so forth, right?
Yes. We'll start out with the A ring, see how tight it is. If it's very tight, we'll have to go to B ring. And all the interior doors are open?
I know, except for that storage room that's locked up downstairs, I believe they are.
It's tight. How many square feet is the house?
About 2,200 living space for that storage room, probably at about 23 or 4.
Okay, it's very tight. Basically, on a regular house, what we would consider, you know, adequately tight, 1 square foot of living area to 1 CFM of leakage. You can see you're at 1180, so you're like 0.5 to 1 for every square foot of living area. You've only got a half a CFM of air leakage, so that's an extremely tight deal.
Which is, of course, again, I've never done this before. This is our first one that we've done, but I am a little bit surprised that you need to jump right up and say that, because my biggest concern here was windows and doors. You know, these aren't lowest end windows and doors, but they're also far from being the upper part of what we could have put in. And you know, they are good, but there's better out there.
But I tell you, a lot of in the 30 years of even old windows, we find that most of the time the leakages are coming from chases and attics, plumbing penetrations, stuff like that, more than windows and doors.
Well, we did really try to seal all of our OSB penetrations, you know, where the electrician had, you know, sawzalled out the outlet. We, you know, sealed that back up, and where the heat and air guys had worked and all that kind of stuff. We tried to seal that all up.
We'll put a pressure pan like over a switch plate like this, and you'll feel, you know, there'll be 20 pascals of air coming through the wall when they drilled the hole and dropped the wires.
Gotcha.
But yeah, a lot of times it's not the windows, even on older construction. Yeah, this one's extremely tight. Like I said, you got about a half a Pascal, not a half a Pascal, but half a CFM per
foot.
foot.
And how does that translate into the air exchanges per hour?
We'll have to do a calculation on that size, and I'll do that in a little bit. We'll get online and get that figured out.
Perfect.
But yeah, I'm going to do a duct test now, but to see what we got flowing through the duct system.
Okay.
Closest weather station, United States, going to be, we'll go Kentucky. We'll go probably from here, Fort Knox.
Probably Bowling Green, Warren County Airport.
Yeah, yeah. Okay, there we go. All right. Floor area.
Let's put in 2,400.
2,400. You know how many people occupy this house? I think we can
varies.
go. Yeah, I think we can go. Okay, dwelling height. So this is from here to the top of that
20 feet, probably.
Call it 20. Okay, measured leakage. CFM was 1120. So now we need to look at like ASHRAE fans, what mechanical fans actually blow out of the house.
So there's 1, 2, 3, 4 of your normal bath brown fan cans.
Gotcha.
So they're pretty low CFM.
Yeah, 36, okay. This will kind of tell you okay, infiltration credits 36 CFMs. Okay, total required. They would want you to have 102 CFMs of ventilation per hour at that leakage rate. So you can get that out of the 3 cans, even if they're just.
But you'd almost need to run them all the time.
Yes, they'd want you running them. Yes, continual. That's what we do for weatherization. Yeah.
So do we, like, to really run that calculation completely right, do we have to put any more information in? Because, you know, like where we put in the 20 feet high, this one room is 20 feet, but versus, you know, basement's 10 feet.
Right, that's the basement condition too?
It is.
Yeah.
And that's counting that footage though, in that 2,400.
Okay,
counting
yeah.
the whole box.
Actually, I guess you would actually figure from the basement because you got stack effect, you know.
Oh, so that's what they're looking for.
Yeah, you're looking at stack
yeah,
effect.
we're really
too.
at, you know, probably 30 feet.
30 feet, yes. Let's see.
If we were looking at like a full-blown ERV on a system, how many CFM is that thing going to be running?
Like I said, that's probably above my pay grade on that.
Gotcha.
Right. Let's see here. I'm trying to pull your ACH up here.
It's looking for a single room.
Yeah, well, I'm just going to go the whole building shell. You said it was 2,400.
Yeah.
They won't. You know the length and the width of the house?
Well, the house is about 30 by 30, so let's just try that and see what we get with
30 by 30. And I'm going to go a 30-foot ceiling from the basement because you're doing the whole.
Yep.
All right, the air filtration. Yeah, this is air. Let me call.
So is that saying 2.5 air exchanges per hour? Explain what this is. So what is this thing we're doing, Steve?
This is a rough looking pressure pan. What we're doing now is we're going to measure leakage, and that's extremely tight. Of course, I guess you're conditioned below. We're reading pressure. So the scale is 0 to 50. 50 would be open your window, you know, outside. It's something to direct hold outside. 0 means it's completely inside the building shell. And you can see your ducts here. They don't get any tighter than that. 0.
And so what is this guy doing? What are we looking at right now? What's it reading?
It's reading a pressure based on the, like I can show you, like this. You have a single window. If you raise the blind there a little bit. That's the pressure we're putting on every surface of the house. There's that much force.
So it's moving quite a bit of air.
That's so much force on the ceiling, the walls, and the floor. So what we can find there is there's that much force on the duct system. So with a 20-mile-an-hour wind trying to get to the duct system, you have 0.2 of a 0, 1. So
but how is it reading is what I'm, what's it trying to read?
It's like I said, it's pulling outside pressure through the duct and then through the pan and into the reference hose, input reference. And so like I said, just a kind of rough measurement, 1 Pascal, if you put a 1-inch Post-it note on your kitchen table and you blew on that Post-it note enough to move it 1 inch, that's roughly how to describe the pressure of 1 Pascal.
And what we're seeing here is just really how tight they got the duct system. So they do a duct blast test as part of their inspection that they have to pass, but then this is really just further proving that they've got the ductwork pretty tight.
Yeah, this is way above and beyond what the state requires. Way above what the state requires. Yeah, that's 1/10 of a Pascal.
Gotcha. So big shout out to Graytac for sealing this thing up good.
Yeah. Yeah, see, that's good. Like I said, I put a pressure pan on a triple gang before and pull a 25 Pascals. So even though you said you're bad at here,
it's not bad. It's the blown in blanket.
Okay, the blown in bibs. Okay.
Yeah.
Well,
which is certainly tight.
Yeah,
but,
it's tight.
You know, we're trying to go to some whole foam systems and.
Yeah. I don't know that you can get much tighter than 0.0.
Oh, I don't know. I think we can. I think we can get even better. So we've concluded the blower door test. We had 1120 CFM at 50 pascals of pressure. And we're going to get with our heat and air company, kind of look at how that calculates into our actual air turnovers and try to see where this house stands. We've got some other projects coming up that we're going to do this on and try to kind of figure out where we're at and what we can do to make it a little bit better. But our goal is to really get these things as tight as we can get them and be in total control of what that indoor areas and what's going on. So stick with us and be sure to subscribe to the channel, give us a like, and we'll see you next time.